Hello everyone. The purpose of this recording is to showcase the use of serverless computing technologies. Just like wireless internet has wires somewhere, serverless architectures still have servers somewhere. What serverless really means is that as a developer, you don't have to think about those servers. You just focus on code and single-handedly build apps that can be shipped to production. You don't have to actively manage scaling of applications. You also don't have to provision servers or pay for resources that go unused. Essentially, you focus on business logic, not servers. In the demonstration that follows, we shall explore a use case that makes use of AWS for enabling serverless computing. The flowchart shown is that of a file format conversion and notification scenario. Let us say a business has a scenario where a bunch of PDF files, which are possibly forms that need filling up, are to be picked up from a source location and remotely uploaded to another destination location. Since the PDF files are uneditable, these first need to be converted into text files. After conversion, a notification in the form of an email should get generated to subscribed users. Using the benefit of serverless computing, all the developer needs to focus are on two things. One, code that performs the remote file upload, and two, the code that converts the PDF to text data format conversion, which effectively means that the tasks like managing of the storage server to store PDF files as well as converted files, triggering the conversion operation as soon as PDF files are uploaded, managing the notification server, maintaining a subscriber base for notifications, all these get delegated to the AWS components that aid in serverless computing. Serverless computing has two variants: backend as a service, function as a service. In case of backend as a service, the backend logic will run on a third-party vendor. Application developer need not provision or maintain the servers or infra which runs the backend services. Backend as a service features include cloud storage, push notifications, user and file management, location services, and many more. Some examples are AWS DynamoDB, AWS Cognito, AWS S3. In case of function as a service, the application developers can implement their own backend logic and run them within the serverless framework. All the scalability, reliability, and security aspects will be taken over by this framework. A function as a service solution provides you the possibility to upload a piece of code which should be executed on specific events. A good example for this is AWS Lambda functions. Both backend as a service and function as a service models are applied to the business requirements specified in the demo. This is a diagrammatic depiction of the AWS serverless components that will be used to implement the business use case. We have the AWS API gateway, from where the call begins. For the demo, a user initiates the PDF files upload by simply invoking the REST endpoint of the Lambda function that performs the storage operation. This invocation is done via the API gateway. Developers can point and click to implement an API gateway for their existing backends in a matter of minutes. They can invoke their code on demand through a REST endpoint. API calls are made from various external apps, are processed by the API gateway, and are routed to Lambda for further processing. With this, we come to the AWS Lambda. In case of the POC, the actual implementation that uploads the PDF files from source to a destination storage is written using a Lambda function. Similarly, the PDF to text data format conversion is written in another Lambda function. Lambda provides a standalone execution environment for individual functions written in Node.js, Java, Python, or C#. Instead of hosting an entire application on a server, you simply upload an individual function to AWS Lambda and call it using one of the many triggers available to initiate a function call. Few of the advantages of using Lambda are reduced cost of execution, simple development deployment as the code is uploaded as a zip or a jar file, automatic scaling without any additional configuration from the developer's side, and it has an event-driven model. Functions can be triggered by events such as events from services like S3 or DynamoDB. Functions also can be triggered as a response to inbound HTTP requests or as a response to inbound messages. AWS Simple Storage Service, S3. S3 is primarily used to back up large volumes of data to the cloud. It is also easy to configure events on S3. For the POC, when the user uploads the PDF files to the specific folder and bucket location, an event is triggered that invokes the second Lambda function. This Lambda function is responsible for data format conversion of the uploaded files. Thereafter, the second Lambda function uploads the converted files back to S3 to another specific folder and bucket location. The other event configured in S3 is generation of notifications as soon as the converted files are uploaded to S3. AWS Simple Notification Service, SNS. SNS is a cloud service for coordinating the delivery of push messages from software applications to subscribing endpoints and clients. For the POC, S3 is configured to trigger event notifications when the converted files are uploaded. This spawns an email notification to subscribers of the S3 bucket where the converted files are stored. Now let us see the demo in action. First and foremost, let us visit our S3 bucket. So we have a bucket called My Awesome Converter. My Awesome Converter bucket has two folders, an input folder in which the PDF files that are meant for conversion get uploaded, and we have the output folder where after conversion, the PDF files that are now into the TXT format are placed. For the purpose of the demo, the source file is placed in the same bucket location. So the source file is called small.pdf. It is placed in the same bucket location of My Awesome Converter. So as you see, this is a simple small PDF file, which right now is present outside the input and the output folders. If we visit the input folder, it is empty at the moment. The output folder is empty as well. Let us take a look at the Lambda functions that have been defined. As mentioned earlier, we have two Lambda functions. The Lambda function that performs the upload, that is, it will pick up the bunch of PDF files and place them into a specific bucket location in S3. In this case, it is the input folder. And then the second Lambda function that does the actual conversion operation from PDF to text and uploads the converted files back into S3 into the output folder location. What we need to do is we need to execute the first Lambda function, that is the uploader function. This Lambda function will be invoked with the help of our API gateway. AWS provides a facility wherein we can directly trigger the uploader function via the API gateway through an event. So let us invoke this function. Both the Lambda functions are nothing but are code that are written in Java. So all we had to do was to generate a jar file and upload these into AWS. So here we see the function results. If we were to look at the logs, we will see that before the upload was done, we simply have the input, the output folder, both of which are empty, and the small.pdf, which we intend to place it in the input folder. So after the upload, the small.pdf is now present into the input folder. Let us verify this by visiting the AWS bucket. So here we have the input folder. If we refresh this, we see that our files are now placed into the input folder. The small.pdf has been placed here. And if you go into the output folder, we see that the PDF file has been converted into text format. So here we go. Apart from that, we have also received a notification that indicates that the small.txt file has been uploaded and placed into the bucket location. The simplicity and cost-saving feature of serverless computing, in combination with not having to write code from scratch anymore, makes this a very appealing technology. Thank you.